Okay. Good morning, students. Today we are going to learn image formation by the curved surfaces. See here, image formation by curved surfaces. So, image formation by curved surface. How we are going to form an image by using a curved surface. Okay, let us see here. There is a one curved surface. This is one curved surface. Okay, this curved surface separated by the two medium. This is first medium. This is considered as air. The refractive index of air is mu1, and this is the another medium. The refractive index of this medium is mu2. Now let us consider this one is called as midpoint of this curved surface. Any imaginary line which is passes through this midpoint is called as principal axis. What we call principal axis. So if you want to form like this, it created one sphere or curved surface or circle. So the midpoint of this curved surface is called as center of curvature. This one is called as center of curvature. Okay, let us consider a curved surface. This is the curved surface which separates the two medium, first medium, second medium. This one mu1 is the refractive index of the air and mu2 is the refractive index of the medium. This is one medium. Now we are going to take one small object, point object, which is taken on the principal axis. This is the point object O. O is the point object. Now I am going to form the image of this object by using this curved surface. So how many minimum rays are required to form the image of the object? Minimum we require 2 rays to form the image of the object. How many rays? 2 rays are required to form the image of the object. So now let us take one ray which is incidented at point A, which is incidented at point A. So this is the ray. So this is the ray which is incidented at point A. This is the point A. Point A. So now this is called as incident ray. Now we are going to draw the refracted ray. So here this is rarer medium. This one is denser medium. So when light ray traveling from rarer medium to denser medium, the refracted ray bends towards the normal. Now we are going to draw the normal for this curved surface. So this one, when light ray drawn from center of curvature to any point on its curved surface, this one acts as a normal. This is the line acts as a normal. The line joining from center of curvature to any point on the surface, curved surface, is called as normal. So in this condition, what we call this line? This angle is called as angle of incident. It is indicated by the letter theta 1. So theta 1 is the angle of incident, which makes an angle incident ray to normal. So we know that when light ray traveling from denser medium to rarer medium, rarer medium to denser medium, the light ray bends towards the normal. So now here this is acts as a rarer medium, this is acts as a denser medium. So now light ray travels from rarer medium to denser medium. Now what happened? Light ray traveling from rarer medium to denser medium, the refracted ray bends towards the normal. So here that light ray, so this is the normal, towards the bends towards the normal means it is bends like this. So this is the refracted ray. This is the refracted ray. So we take in one ray, one light ray which is incidentally at point A. This is point A, and it is refracted. When light ray traveling from rare medium to denser medium bends towards the normal. So what we call this angle? This angle is called as angle of refraction. It is indicated by the letter theta or symbol theta. Angle theta. So angle of incidence theta 1 and angle of refraction theta 2. So how many minimum rays are required to form the image of the object? Two rays. So this is one ray. Next, one more light ray which is passes along the principal axis. It is undeviated, which is undeviated. So these two are intersected at this point. So this is at this point we are going to get image. So here the point of intersection of two refracted rays gives us a real image. So this is the image formed by this curved surface. So now let us assume this is the height h. This is the height h from the principal axis. So this is the optical center or pole of this curved surface P. So this one is called as P dash. Here these are the rays are called as paraxial rays. The gap between these two is very close. That's why we are assuming P is equals to P dash. P is equals to P dash. So now let us see here. Let us see here what we call the distance between object to pole. We called as object distance. So this is indicated by the letter U. This is the object distance. And the distance between pole to image is called as image distance, which is indicated by the letter V. This is the V up to here. Okay. So now from figure we are going to observe some triangles are formed, and here this incident ray makes an angle alpha with the principal axis. Let us assume this is the ray. This one makes an angle alpha with the principal axis, and this normal makes an angle beta with the principal axis, and this refractor ray makes an angle gamma with the principal axis. And let us assume this height a to p dash is considered as h for our convenience. This height. Okay, this is the diagram when object is placed in a rarer medium and image is formed in a denser medium. I is the image, O is the object. So from this figure, from figure, from figure, from figure we observe there are different triangles. So now here triangle OAC, triangle OAC, and triangle ACI, from triangle ACI, from triangle AC. So there are different triangles we formed in this diagram. So from the diagram we are going to observe two triangles. Now first of all we take a from triangle OAC. From triangle OAC there is one rule. OAC, exterior angle is equals to sum of the two opposite interior angles. From this figure, exterior angle from this triangle, exterior angle is equals to theta 1. Theta 1 is equals to sum of the opposite two angles, alpha plus beta. So now here from figure. So from figure, theta 1 is equals to alpha plus beta. This is equation 1. So exterior angle is equals to sum of the two opposite interior angles. So next one, from triangle ACI. This is the ACI. From triangle ACI. Here also we are going to get exterior angle from this triangle. ACI is the exterior angle. Here beta is the exterior angle. Beta is equals to sum of the two opposite interior angles, theta 2 and gamma. So now here theta 2 plus gamma. So now triangle ACI. Here external angle is equals to sum of the two opposite interior angles. What we call opposite to interior angles. Theta 2 plus gamma. From this equation, I am going to take here theta 2 is equals to beta minus gamma. Beta minus gamma. Okay. This is considered as equation 2. Equation 2. Okay. Now we are going to take one law, that is nothing but Snell's law. So Snell's law at A. So Snell's law, Snell's law at A, point A. So we know that Snell's law, n1 sin I is equals to n2 sin R. So here n1 is the refractive index of the first medium. So what is the refractive index of the first medium? N1, because the light ray traveling from medium 1 to medium 2. That's why refractive index of the first medium is mu1. And sin I. What is the angle of incident here? This is the angle of incident theta 1. Theta 1. That is equals to n2. N2 is the second medium refractive index mu2. So here mu2 into sin r. What is the sin r here? R is equals to theta 2. Sin r is equals to theta 2. Here these angles are very very small. Here angles are very small. What we call very small. Angles are very small. That is sin theta or theta 1 is approximately equals to theta 1, and sin theta 2 is approximately equals to theta 2. So here angles are very very small. If angles are small, sin theta 1 is approximately equals to theta 1 and sin theta 2 is approximately equals to theta 2. That means here theta 1 becomes theta, sin theta 1 becomes theta 1 and sin theta 2 becomes theta 2. So again we are going to write this one mu 1 in place of sin theta 1 only theta 1. That's why mu 1 theta 1 is equals to mu 2 theta 2. So here mu1 theta 1 is equals to mu 2 theta 2. So in this diagram and previous diagram mu1 theta 1, what we call here theta 1, here theta 1, here theta 1. Here theta 1 can be considered as alpha plus beta. Theta 2 is equals to beta minus gamma. Now we are going to substitute that values. So theta 1 is equals to alpha 1 plus beta. That is equals to mu 2 into theta 2. Theta 2 is considered as beta minus gamma. Beta minus gamma. So now here this is theta 1 alpha plus beta, theta 2 beta minus gamma. Beta minus gamma. So now we can multiply this is mu 1 alpha. So mu 1 alpha plus mu 1 beta. That is equals to mu 2b. So mu 2 beta minus mu 2 gamma. Mu 2 gamma. So now here beta transfer this side, this one transfer this side. So now here mu 1 alpha, this minus goes this side becomes plus. So mu 2 gamma, that is equals to mu 2 beta minus, so mu 1 beta. So now here mu 1 alpha plus mu 2 gamma, that is equals to mu 2 minus mu 1 into beta. So let us consider this is equation 3. Now we are going to get alpha, beta, gamma values from the diagram. Okay, let us see here. This is the diagram alpha, beta, gamma. So now there is a angles. Either we are going to choose alpha, that means sin alpha, cos alpha, tan alpha. Either sin, cos, tan. So if you want to take sin alpha is nothing but opposite side by hypotenuse, but there is no any particular name for hypotenuse. So hypotenuse is OA incident ray, but adjacent side, opposite side, opposite is a height h, and adjacent side is object distance, image distance, radius of curvature. So there is a convenient names along the adjacent sides. That's why you are going to prefer tan theta. From this diagram, tan theta is equals to, this is the alpha. So tan alpha, alpha beta gamma. Tan alpha is equals to opposite side by adjacent side here. Tan alpha, this is the alpha. Opposite means h. By adjacent side means p dash o. And p is equals to p dash. That's why po. Similarly, tan beta is equals to, this is the angle beta. Tan beta is equals to opposite side by adjacent side, p dash e. P is equals to p. P dash is equals to p. That is pc. Similarly, tan gamma is equals to opposite side by adjacent side. So like that we are going to get, first of all, tan alpha. Tan alpha is equals to h by p dash o. Tan beta is equals to h by p dash c. Tan gamma is equals to h by p dash I, like that. So first of all, tan alpha. So here we are going to take a tan alpha. Here tan alpha is equals to, so opposite side is nothing but h by adjacent side. So opposite side is h, adjacent side is p dash o, p dash o. So now p dash o, that is equals to h by p o. So here also angles are very very small, that's why is approximately equals to alpha. Similarly, tan beta, tan beta. So tan beta also opposite side by h by p dash c, p dash c. See here, tan beta from the figure, tan beta from the figure, tan beta from the figure, opposite side by adjacent side, p dash c, p dash c. So that is equals to h by p dash is equals to p, that is pc. This is approximately equals to beta, this is also beta. Similarly, tan gamma, tan gamma also opposite side by adjacent side, p dash I, that is equals to h by pi. This is approximately equals to gamma. So this alpha, beta, gamma values are substitute in this equation. Substitute above equation. Let us see here. Let us see here. From this equation, mu 1. So this is mu 1 alpha. What is the alpha value? Alpha is equals to h by po. H by po plus mu 2 gamma. So mu 2 into gamma. So gamma means h by pi. So that is equals to mu 2 minus mu 1 into beta. Beta is equals to h by pc. H by pc. So now here h common, here h common, and here this h and this h common, and with h gets cancelled. Now finally we are going to get here mu 1 by po, mu 1 by po plus mu 2 by pi, mu 2 by pi, that is equals to mu 2 minus mu 1 by pc. Mu 1 by po plus mu 2 by pi, that is equals to mu 2 minus mu 1 by pc, mu 2 minus mu 1 by pc. So from the figure we conclude that here mu 1 is the refractive index of the first medium, mu 2 is the refractive index of the second medium. At the same time, what we called PO, PO is equals to object distance, PC is equals to radius of curvature, PI is equals to image distance. So the distances from, this is considered as a x-axis and y-axis. From right side we sorry, right side we consider as positive values, left side we consider as negative values. According to sign convention, PO is left side, negative x-axis. So PO is considered object distance, it becomes negative. PC radius of curvature positive, PI image distance positive. So according to sign convention, PO is the object distance, PC is radius of curvature, PI is the image distance. So let us see here. Here PO, PI, PC are there. Now according to sign convention, according to according to sign convention, according to sign convention, according to sign convention, PO is equals to object distance. Object distance. So this object distance is always negative in left side. That's why minus u. And PC is equals to radius of curvature. Radius of curvature. Radius of curvature. It is indicated by the letter. So R. This is right side of the axis, right side, that means on positive x-axis, that's why R plus R. And PI is equals to image distance. Image distance. Image distance can be taken as V. This is also positive because they given from the diagram. This is PO opposite to the positive, that is negative axis from here to here, minus U. PC radius of curvature plus R, and PI image distance plus V. So now by using this equation we are going to take mu1 by PO and mu2 by PI is equals to mu2 minus mu1 by PC. So here mu1 by PO, that is mu1 by PO. PO is nothing but minus U and plus mu2 by PI. PI is nothing but here V, that is equals to mu2 minus mu1 by R. R is nothing but R only, plus R. So this one, based on this one, this is minus, this is plus, that's why we are going to write first plus value. Mu2 by V and minus mu1 by U, that is equals to mu2 minus mu1 by R. This is the equation we call as image formation equation. What we call image formation equation. So here mu1 is equals to refractive index of the first medium. Refractive index of first medium. Index of first medium, and mu2 is the refractive index of second medium or curved surface. Second medium or curved surface. Okay, next one, U is object distance. Object distance. U is object distance. V is image distance. Image distance. U is image distance. Next here R. What we call R? R is equals to radius of curvature of the curved surface. Radius of curvature. Radius of curvature. So this is called as image formation equation. What we call image formation equation. What we call image formation equation. So let us see here. This is the diagram. Based on this diagram, we can calculate. Let us see how we are going to solve the problems by using this equation. This is the formula, mu2 by V minus mu1 by U is equals to mu2 minus mu1 by R. By using this equation we can solve one problem. Let us see here. If they given one diagram like this, so this is one curved surface, this is one curved surface like this. So what we call this is, this one we call as principal axis. This is a pole, and this one is called as center of curvature. This is pole. This one we call as center of curvature. And here one object they given. This is one object which is 20 centimeters from the pole, and this is we call as radius of curvature. This is 15 centimeters is the radius of curvature. And here mu1 they given 1, and mu2 they given 4 by 3, 4 by 3. Then find the image, position of the image for this object. Let us consider one object which is placed in medium 1 of refractive index 1. So which is 20 centimeter from the curved surface, and the radius of curvature of this curved surface is 15 centimeter, and refractive index of this medium is 4 by 3. Then find the position of the image. Then find position of the image. So now we go for solution. Let us see here they given what they given. Mu1 is equals to 1, mu2 is equals to 4 by 3, and they given radius of curvature this side plus, so 15 centimeter, and object distance is always negative opposite direction. This is the object distance minus 20 centimeters. Now position of the image is equals to question mark. So we know that mu 2 by v minus mu 1 by u, that is equals to mu 2 minus mu 1 by r. Mu 1 by r. Now mu 2, what is the mu 2 value here? 4 by 3. So now here 4 by 3 by v minus mu 1. What is the mu 1? 1. 1 by u. What is the u value here? Minus 20. Minus 20. That is equals to mu 2. 4 by 3. 4 by 3 minus 1 by r. R is equals to how much? 15. 15 plus 15. So this can be written as reciprocal means 4 by 3v and minus into minus plus 1 by 20, that is equals to here LCM 3. So now 4 minus 3 by, so 3 into 15. 3 into 15. This can be written as 4 by 3v, 4 by 3v, that is equals to 1 by, so 4 minus 3, 1 by 3 15s are 45. 45. This one transfer this side becomes minus 120. So now here 4 by 3v, that is equals to here LCM. So with respect 20 and 45 LCM, 20 and 45 LCM, 5 fours, 5 nines. So now here 5 fours 20, 20 nines are 180. This is 180 LCM. So now 180, 45 goes 4 times. 4 times, this is 4, and 20 goes 9 times, this is 9. So now here 4 by 3v, that is equals to minus 5 by 180. Minus 5 by 180. Now here 3 ones, 3 60s. So now here 5 ones, 5 ones, 5 12s. So now here 4 by v is equals to minus 1 by 12. So now here v is equals to minus 48 centimeters. Cross multiplication minus 48 centimeters. So in this way we are going to solve the problems by using image formation equation. Okay, thank you.